Welcome to Across the Globe. Today we will learn about security in PHP. Security in PHP is crucial for safeguarding websites and applications against malicious attacks. By implementing proper security measures, such as input validation, parameterized queries, and data encryption, developers can mitigate the risk of unauthorized access, data breaches, and other vulnerabilities. For example, ensuring that user input is sanitized before processing it can prevent SQL injection attacks, where malicious code is inserted into queries to manipulate databases. Additionally, using encryption algorithms like HTTPS can secure data transmissions between clients and servers, reducing the chances of eavesdropping and data tampering. Overall, prioritizing security in PHP coding practices is vital for protecting sensitive information and maintaining the integrity of web-based systems. Cross-site scripting, XSS, is a prevalent security vulnerability where attackers inject malicious scripts into web pages. Exploiting user input fields, like in the PHP code snippet shown, enables attackers to execute harmful scripts. For instance, if a user enters script alert XSS attack script as their name parameter in the URL, the script would be displayed on the web page, demonstrating a simple XSS attack. SQL injection is a security vulnerability where attackers insert SQL code into input fields to manipulate database queries. By exploiting this flaw, unauthorized access to sensitive data can be gained. For instance, in the PHP code snippet provided, if an attacker enters SQL code like or11 as the password value, the query would return all users, granting unauthorized access. To prevent SQL injection, parameterized queries or stored procedures should be used to sanitize and validate user input before executing SQL queries. Cross-site request forgery, CSRF, is a type of attack where a malicious website tricks a user into executing unauthorized actions on another website where they are already authenticated. An attacker may craft a URL or form that, when accessed by the victim, unknowingly triggers actions on the legitimate website. For instance, an attacker can create a hidden form that automatically transfers money from the victim's account on a banking website without their consent. This can occur because the victim is logged into the banking site and unknowingly submits the form initiated by the malicious website. Website developers can prevent CSRF attacks by using techniques like unique tokens per session to verify the authenticity of the requests. To safeguard your system from malicious data, always validate and sanitize user input. This prevents the risk of attacks such as cross-site scripting, XSS. Utilize functions like filter var to validate input based on filters and htmlspecialchars to convert special characters to HTML entities. In the given PHP example, the input containing a script tag is sanitized using htmlspecialchars to prevent an XSS attack. By incorporating these practices, you enhance the security of your system and maintain data integrity. To securely store passwords in a database, use hashing functions like password hash to hash the passwords before storing them. This helps protect the actual passwords in case of data breaches. For example, in PHP, you can hash a password using password hash function. Password 123, $hashed password hash, password default. Later on, when you need to verify a password at login, use password verify function. It compares a given password with its hashed version to check for authenticity. Ensure you choose a strong hashing algorithm and store the hashed passwords securely. It's a good practice to salt the passwords before hashing for additional security. Security in PHP is vital for safeguarding websites and applications against attacks. Developers should adhere to best practices like data validation, password hashing, and protection against common vulnerabilities to bolster security. For instance, validating user input prevents SQL injection attacks, while securely storing passwords with hashing mechanisms averts data breaches. By addressing vulnerabilities proactively, developers can fortify the security of their PHP applications and uphold the integrity of sensitive data. Think of a PHP program as a locked safe that holds valuable information. Security measures in PHP are like the combination lock on the safe, ensuring that only authorized users can access the information. Just like how you wouldn't leave the combination to a safe lying around for anyone to see, you need to properly secure your PHP code to prevent unauthorized access. Implementing secure coding practices in PHP is like fortifying the safe with additional locks and safeguards, making it even harder for intruders to break in. Hey, code conquerors, ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance, coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The safe class in this PHP code acts as a secure vault for valuable information, with its combination property functioning as a digital lock. Access to the safe is granted through the open safe method, which requires the correct combination for entry. By closely mimicking the security mechanisms of a physical safe, this code demonstrates the significance of safeguarding sensitive data in PHP applications. Unauthorized access attempts trigger an alarm within the program, emulating real-world security protocols to protect against potential breaches. In practical scenarios, this code could be employed to secure user authentication data, ensuring that only authorized individuals with the correct credentials can access restricted information. By leveraging secure coding practices and adopting a multi-layered security approach, PHP developers can enhance the protection of their applications and shield valuable data from unauthorized intrusion. One real-world application of security in PHP is in e-commerce websites. When customers make online purchases, their sensitive information, such as credit card details, need to be securely handled to prevent unauthorized access or data breaches. PHP is used to implement secure payment processing systems, encryption techniques, and access controls to safeguard this sensitive data. Another example is in enterprise applications that deal with confidential business data. PHP is commonly used to develop internal business systems where employee data, financial records, or trade secrets are stored. Implementing security measures such as user authentication, role-based access control, and data encryption in PHP helps protect this sensitive information from unauthorized access or cyber attacks. In both scenarios, incorporating security practices in PHP development is essential to protect valuable data and ensure the integrity of the systems. Across the globe, businesses and organizations rely on PHP to build secure applications that guard against potential threats and vulnerabilities. Keep learning, stay curious, and I'll catch you in the next video.